Hey guys, welcome back, and today we'll be discussing the LeetCode question of September 1, that is array nesting. So let's start with it and let's look over the question. So the question says that it contains an array which is basically a permutation in the range of 0 to n minus 1. What it means is that suppose if we have a vector of length equal to 4, it means it will contain 0, 1, 2, 3 element for sure, but in any permutation combination it can be 3, 0, 1, 2, or it can be some other any other combination. And let's take another example, length 3, so it will contain 0 1 2 2 1 0 or such combination. Okay, so what it means is that no element is actually repeated over here. So please note this: no element is repeated. It will come handy later on to build up a solution. So let's start taking the example over here. So the example says that it is 54036162, right? So let's deal with this example. 54403162, and we will have some index. I will write down the index for you for better understanding. So the purple thing is indicating the index, and I'm going to be using different color, green maybe. So let's start. Okay, so this question start with saying that we started trading from the zeroth index, and the zeroth index says contains a value of 5. Now 5 says that you have to visit the fifth index. The fifth index here contains a value of 6. Now using the sixth value, we are going to be visiting the sixth index. Now the sixth index here is contains a value of 2. So now we have to visit the index 2. What value index 2 contains? 0. So we'll go back from 2 to 0. Now we have to again go back to the zeroth index here, and we are back where we started. So basically when we write it down, it's something like this. Okay, 540 562 0, and finally we are back again. And what will happen with 4? The 4 says that you have to visit the what fourth index, and the fourth index contains a value of 1, and the 1 says that again contains a value of 4. So basically it is a cycle within itself, and the 3 is basically pointing to itself. So 3, I go to 3 contains an index of so it says that visit the third index, and again it is the same element. So after drawing this, what I can conclude is that the in degree of all these are 1. Okay, so if you notice the in degree, it is exactly equal to. So if, for example, the we have an in degree from 5 here, okay, the arrow which is going over here. So no element is having 2 in degree. What this means is that we cannot have something like this, right? Because it makes the whole solution, where whole approach different. We can say that, for example, what if the in degree was not equal to 2? Let's suppose. So if in degree was not equal to 2, that means that the fifth can actually point to some other element. If the fifth goes to this one, okay, I'm sorry, we'll just change it. So we can have something like this: 2, 3, and 4. Okay, and if in degree had been equal to 2, had been, please note it is not in this question, and here it could have been something like 6, 7. 7 goes to 8. It is not for this example. So here what will happen if the in degree was 2? We would have 2 cycles, one with length of 1 2 3 4 5, and one with length of 4. So that is an overall different question that would have been much more complicated, but that's not the case here. So 5 can only form a cycle with either this one or this one, right? And if we check this out, the fifth will always point to the nums 5. Fifth will always point at nums 5, right? So that means it can only form a cycle with this element, and this element can only form with cycle with nums nums 5. So it goes on, right? I hope you're able to understand the question. Now we're going to come building approach. So there is two things. Okay, while visit we can first thing is that iterate all the elements. So that's true that we have to iterate all the elements, because in the worst case, every element can be at its initial position 0, 1, 2, 3, 4, 5, and 0 will be pointing at 0, 1 will be pointing at 1. So we have to iterate all the elements here. Next thing is that uh, we have to make sure is that we are not visiting the same value again and again. For example, if we have found the cycle with 5620, there's no meaning to visit this 6 again, this 2 again, or this 0, right? Because we have already visited this while traversing for the 5 and building up a cycle. So when we have visited this, we have to do something. There's two options. Either we can have something like vector bool. Now this what vector bool can do is that for every element visited, we'll mark it as true. Initially it will be set to false, but if we visit 5, we mark it true. If we visit 6, we mark it true. And if we visit 2, we'll mark it true. And if we visit 0, we mark it true. So next time, the condition would be something like we have to check if if we give the names called x, if the x is actually x is equal to x dot I, no, I mean x dot I is equal to true. So that means skip, else visit. So that is the thing we can do. But there could be, that would involve time complexity will be O of 1, because we are iterating all the elements, but the space complexity will also be O of n, right? Because that would, we are making a separate vector. What if the interview tells you that you do not have to use space, and the space complexity is something called O1? What do you have to do in that case? Now comes a tricky thing. So what comes to my mind is that when we visit all these elements, we can actually change this value. For example, I visit 5 and I store this 5 in cert variable x, and I store. I'm sorry, it's not a JavaScript, but I'm just using some variable. Let's call it variable x, and we store this value of 5 in variable x. Call it, and after storing this, I change it to -1. And after changing to -1, we visit the next value. Okay, after doing so, if we arrived at 0, what would be the next element would be pointing to? Okay, you might be thinking 5. No, it's not 5, it's actually -1. It would be -1, yeah. So 0 would be pointing at -1. And what does -1 means? The -1 basically means that we have visited the whole cycle again. Okay, are you able to get me? Yes, that's the question, and that's the solution we are going to be building around. Okay, let's start coding. And remember that we are actually interested in storing the max length of the cycle. So for that, you have to just use the max variable to just store the max value. Okay, let's start. So the first thing that comes to my mind is that I have to return an answer. And answer, I just mark it 0 and I just return it. Fine. And next thing I told you is that I have to iterate all the elements. So I start iterating all the elements over here for the num_sci. And I told you that I'll be using a key value. Int k is equal to I. Now I will tell you why. And nums is basically greater than equal to 0, because if less than 0, we have started. Okay, and so if it is less than 0, that means it contains a -1. If it contains -1, means that we are back to where we have started. So I told you we have to use a temporary variable to store the value of nums_k. Now I will tell you why. Because we are actually changing this nums_k value to -1. And once we have changed the value to the -1, what we have to do is that, okay, there would be a count variable as well. Why count? Because we are interested in storing the length of the cycle. So notice here the length here is what? 1, 2, 3, 4. The length is 4. What is the length over here? 2. And what is the length over here? 1. So you're able to get. And we have to always store the max length. So how we going to do is that every time we visit another variable or another element, we're going to increase the count. And last thing is that we have to store the max possible value in the answer. So it will be the max of answer. So basically between 2 and 4, it will be always 4, right? So and count. And that's it. Okay, let's check it if it runs or not. Okay, that means we have done a mistake. And let's see where we have actually done the mistake. So I will initialize the count to 0, right? And it's num k greater than equal to 0 and have int k is equal to I. That means that I am just visiting the k again. And after visiting, I am going to check if it is greater than equal to 0, because if it is less than 0, that means we have iterated the same route again. I'm going to check for the temp value here over here. Okay, I have to change the value of the k as well. Are you getting me? Because since we visited from 1 to 6, what we have to do is that we have to change the value of the k. Now, what will be the new value of k? Basically, it will be equal to temp. We have missed the statement. So the why temp? Okay, so because the temp will be the next index, it will be pointing to the next element over here. For example, the fifth will point to the fifth index, so it will basically point to 6, and hence this was causing a problem. Now I hope it will run. Perfect, it runs perfectly, not an issue. Okay, it runs fine, but can we come with another approach? Okay, this was a O of n approach. Can we come with another approach? Let's think about it. Yes, there is definitely another approach, and that's called DFS, right? So in the DFS, what we have to do is that we have to start visiting. So for example, it works the same way as this. What we have to, we start with 5, we go to 6, and then it's the same thing if the visited is actually equal to false. But that will involve a space complexity of on, and I don't think so it would be a good approach when you're coming with to an interview, because the interview would be expecting something like a O of one time complex space complexity. And yeah, so you can actually try with the DFS as well. That's not an issue. So we would have something called vector bool as well here. So here I had told you two things. Either we can actually change over the value in the vector itself, or we can actually initialize a new vector which will contain the false. Okay, everything would be false, and after visiting every element, we will mark it true. And we can actually, after every recursive call, we can do is that we can actually store increase the count. Okay, for every recursive call, like we do a recursive call to 6, so I increase the count, and we do a recursive call to 2, and I increase the count. So it works a similar way, and that would be another good solution. So yeah, guys, that's it. I hope you're able to understand, and if there is any other problem you're facing, you can actually put down in the comments. And thank you, guys.